Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 3 of a unit motion in a straight line. In previous classes, we have studied about the average velocity and average speed. And at that point of time, we have discussed that there are two kind of speeds or velocity primarily. One was the average and another was the instantaneous. So let's today begin with the instantaneous velocity. Now, what is instantaneous speed and velocity? We say that if I measure instantaneous speed, that means I am going to measure a distance covered at a particular instant of time. You should focus on this. I am going to measure a distance at that instant of time. Well, I am going to consider instantaneous velocity. I am going to measure a displacement covered at particular instant of time. So whatever I am going to do, that will be done for that instant of time, and when that is to be done on that instant of time, I need to measure instantaneous speed or instantaneous velocity. But what is it and how it can be calculated? So let's say what would be the situation will that suppose a certain particle is moving and it has traveled delta x and within from t to t plus delta t. You can say something like this, that this is the motion, and let's say this is the time t. We are going to take one more instant, this is t plus delta t, and within this much amount of time, from starting from t to t plus delta t, a particle has traveled delta x distance. So when we are used to measure the average velocity or average speed, what is it? It's an v average would be equals to delta x by delta t. It is a total distance traveled divided by total time taken. But let's say if I want to reduce this time, so let's say I will take an observation here, and let's say this is t plus delta t1. I want to reduce more it. Let's say it would look like this. If even at this point I want to go for the sharper edge, then I just make a certain situation where where this this delta t approaches to 0. Now all the students which are from the engineering background, all those who learn this, they are comfortable with this. But for the medical background students, they don't know this. Whenever I say delta t approaches to 0, this is certain kind of function. It's a limit function. And delta t, this is what we call as in delta t tends to 0. What does it mean is that is delta t is very near to the 0. We can say something like this, but it is not a 0, but it is very small, so we take as an as delta t approaches to 0, the distance delta x also approaches to 0, but delta x by delta t has a finite limit, and that limit can be calculated, that limit can be given as v is equals to limit of delta t tends to 0 delta x by delta t. That means if I consider delta t a very smaller amount of time, then I would be having, an delta x would be a very smaller amount of time, and the ratio would be the v. Am I clear with this? Are you sure? Okay, let's move on. So what is instantaneous velocity? Basically, what is instantaneous velocity? We can say that, let's say delta r is the displacement in the time interval delta t. Then if I want to write out the instantaneous velocity v of the particle at time t, then I can write like this. It's a limit delta t tends to 0. Delta t would be a very smaller amount of time. Then we know that speed is equals to distance divided by time. I'm doing the same thing. It's a distance Let's say if it is a velocity, it is a displacement divided by time. So this is displacement, this is time. This is the same situation. It's a displacement by time, but time is very less. So if this is the function of a limit, we can write like this. This is d by dt of r, and here the differentiation started playing its role. This is what we can say is we are going to, this is v is equals to dr by dt, v is equals to dr by dt. This is differentiation of r with respect to time. This is differentiation of r with respect to time. Now let's look a little that what is differentiation and what does it mean and all that stuff. Let's say, let's say I want to find out delta y by delta x, but if delta x is very small, then I can write like this. Let's say z is equals to dy by dx. This is differentiation of y with respect to x. Understood? Yes. One more term. Let's look at this. We know that acceleration is equals to change in velocity divided by time. So you can write like this: a is equals to delta v by delta t. A is equals to delta v by delta t. Now if this delta t is very small, if this delta t is very small, then I can write like this: a is equals to d by dt of v. This is differentiation of velocity with respect to time. Can you understand now? Now these are the certain differentiation basic formulas. When we are going to learn up in this lecture will be the differentiation. We are going to practice those functions. We are going to practice those functions only which have significance according to the physics. So we are going to practice that and then we again switch to the physics. So look at this. We are directly going to see the basic formulas. This all are the basic formulas. Let's say if any constant is there, if any constant is there, then differentiation of any constant would be a 0. Look at this. This is d by dx of k, while k is a constant. So I should write is this d by dx of k, and k is a constant, so their answer would be a 0. Let's look at this numerical: d by dx of x to the power n, d by dx of x to the power n. So in this function, while I am going to apply a differentiation on this, then the answer would be a n into x to the power n minus 1. What I can say is I need to multiply with the power, and one power would be a lesser. I need to multiply with a power and one power would be a lesser. So let's look at this. This is d by dx of x, that means x to the power 1. So when I can apply this, this is the general relation for n number of terms. So this is d by dx of x to the power 1. So when and when apply this rule, the power, it would be a 1 multiplied by 1 power would be a lesser, that's an x to the power 1 minus 1. So when I apply this, this is 1 into x to the power 0, and when x to the power 0, it is 1 itself. So 1 into 1, this comes in 1. So this is the situation. Got it? Yes. Now let's look to the new function. It's a d by dx of kx, where k is a constant. So when k is a constant, then you can write like this: d by dx of k into x, while k multiplied by d by dx of x. Now you know that d by dx of x is 1. D by dx of x is 1, so this comes to nk. So if you remember this relation, if you remember this relation, things would be easier for you. Got it? That you need to focus on this too. When any constant is there, when any constant is there, and that is to be differentiated, then the answer would be a 0. And next, when if a certain term is there which is having a significance or similarity with the d by dx of x to the power n, then it would be an n into x to the power n minus 1. Are you clear with this? Let's practice these things. Let's say they have given, d by dx of x to the power 5. Now what I should do is, first I need to compare this with any standard result, that is d by dx of x to the power n, which is equals to n into x to the power n minus 1. So when I do this, for me n is equals to 5. For me in this case, n is equals to 5. So what I can do is d by dx of x to the power 5. The power would be multiplied. This is 5 multiplied by, and one power would be a lesser. This is x to the power 5 minus 1. So that tends to a 5 into x to the power 4. Got it? Are you sure? Okay, let's look next. Suppose they have given d by dx of x to the power 7 plus x to the power 5 plus x to the power 3. Now what would be the situation? I need to compare these terms with d by dx of x to the power n, which is n into x to the power n minus 1. Now tell me, what should be the answer? How could I do this? First, x to the power 7 power would be multiplied. 7 multiplied by 1 power would be a lesser. So this is x to the power 7 minus 1. Can you do it? Are you sure? Okay. Next, plus x to the power 5. So power would be a multiplied. This is 5 multiplied by x to the power 5 minus 1 plus x cube. This is 3 multiplied by x to the power 3 minus 1. So this tends to 7 into x to the power 6 plus 5 into x to the power 4 plus 3x square. What was your answer? Is it the same? If yes, very good. If no, don't worry, we have more questions to do. But do one thing: take your book, take your paper, and do it with me. This will help you. So let's take a next questions. Y is equals to x square plus 1 by x square, and they ask find out dy by dx. It's a differentiation of y with respect to x. So what it would be? This is d by dx of x square plus d by dx of 1 by x square. It seems like this. So while I perform this, it is d by dx of x square plus d by dx of x to the power minus 2. Yes. Okay. Now power would be multiplied. This is 2 into x to the power 2 minus 1 plus here d by dx of x to the power minus 2. So stick to the basics. They are the power minus 2 multiplied by x to the power minus 2 minus 1. because standard relation is d by dx of x to the power n, and that stands to n into x to the power n minus 1. So now if I solve this, it is 2 into x to the power 2 minus 1, that stands to a 1, plus minus of 2 into x to the power minus of 3. So this is 2x minus 2 divided by x cube. This is the value of a dy by dx. This is the value of a dy by dx. Got it? Next, let's say they have given us that y is equals to x square plus 1 by x square plus root x plus 1 by root x, and you need to find out dy by dx of this. You need to find out dy by dx of this. So this is d by dx of x square plus d by dx of x to the power minus 2 plus d by dx of x to the power half plus d by dx of x to the power minus half. Am I clear with this? Yes. Next, d by dx of x square, what it would be? Now you know by mental calculation as well. It's a 2 into x to the power 2 minus 1. It's an x plus minus of 2 into x to the power minus 2 minus 1 plus this is x to the power half, so this turns to an half into x to the power half minus 1 plus this is minus 1 by 2, so this is minus 1 by 2 into x to the power minus 1 by 2 minus 1. So if things are like this, this is 2x minus of 2 into x to the power minus of 3 plus half into x to the power half minus 1, it's a minus half, plus into minus, it's a minus 1 by 2 into x to the power minus 1 by 2 minus 1 minus 3 by 2. So if I write it like this, minus 2x divided by 2 divided by x cube plus half into 1 by root of x minus of 1 by 2 into x to the power minus of 3 by 2. Yes. Okay. After this, if there is a requirement of solution, then you can apply a basic mathematics and you can solve this. But are you clear with this? Are you? Do you find this interesting? Let's do more practice. Let's say they have given that z is equals to t square plus 3t plus 7. What they required is they required a dz by dt. Now what I need to do is I need to differentiate z with respect to t. This is d by dt of t square plus 3t plus 7. So this is d by dt of t square. This things should seems like this, dt of 3t plus d by dt of z. So d by dt of t square, it is 2t, d by dt of 3t, it is 3. Now this is 7, it is a constant, and as previously discussed, differentiation of any constant number would be a 0. So d by dt of 7 would be a 0. So this comes to a 2t plus 3. Yes. What was your answer? Was it the same? Are you sure? Okay, very good. Now let's look at the next. Let's say they have given that z is equals to theta cube plus theta square minus theta to the power 1. And what you required is, it is a dz by d theta. It is differentiation of z with respect to theta. How can you do this? So this is d by d theta of z. This is equals to d by d theta, d by d theta of theta cube plus d by d theta of theta square minus d by d theta of theta. So when I perform d by d theta of theta cube, it is 3 multiplied by theta square plus 2 multiplied by theta to the power 2 minus 1, that stands to a 1, minus d by d theta of theta. Theta, that means a power 1 is there. So this is power 1 multiplied by theta to the power 1 minus 1, it would be a 0. So this comes to an 3 into theta square plus 2 into theta minus of 1 into theta to the power 0. Theta to the power 0 would be a 1. So this is 3 theta square plus 2 theta minus of 1. This is set. Are you clear with this? So I hope these two functions are clear to you. These two functions are clear to you. Now let's look at certain new basic functions. They are the logarithmic and exponential function. So first look at this, d by dx of log x. It's an ln x. D by dx of log x, it is 1 by x. D by dx of log x, can write like this. It would be a 1 by x. D by dx of log x, it's a 1 by x. And d by dx of e to the power x, it's an exponential function, that you know. D by dx of e to the power x, it is the same. It is the e to the power x itself. So d by dx of log x or d by dx of ln x, it's a 1 by x. D by dx of e to the power x, it's an e to the power x. And d by dx of a to the power x, look at this, d by dx of a to the power x, then it would be an a to the power x multiplied by log a. Please do remember these functions. This will help us to calculate numericals. But before that, you need to remember these things. Now let's practice this. Suppose they have given that d by dx of e to the power x plus log x. How could I do this? So it should be d by dx of e to the power x plus d by dx of log x. Now when I do this, d by dx of e to the power x, it would be the same. This is e to the power x and d by dx of log x, this is 1 by x. What was your answer? Was it same? Was it? Great work. Next, let's say d by dx of x square plus x to the power minus 2 plus ln x plus e to the power x, and I need to solve this. So when I do d by dx of x square, it is 2 into x plus d by dx of x to the power minus 2, it is minus of 2 into x to the power minus 2 minus 1, this is minus 3, plus d by dx of ln x, it's a 1 by x, plus d by dx of e to the power x, this is e to the power x. So this should be 2x minus of 2 divided by x cube plus 1 by x plus e to the power x. This would be the answer. This would be the answer. Get it? What was your answers? Were they same? Yes? Well done. Next, let's say they have given like this, d by dx of log 2 to the base 10. Now what was the answer? You need to differentiate log 2 to the base 10 with respect to x. What would be the answer? Tell me. Do you know this is a constant number? Do you know this? What is the value of it? Did you remember this? Yes, it is approximately 0.3010. And differentiation of any constant number would be a 0. Even this value does not require to have this answer. We must know that this is a constant number. We don't know what the number may be, but we know that it is a constant, and when it is a constant, its a differentiation would be a 0. Are you clear with this? Yes. Let's look at this one. E to d by dx of e to the power x plus log of a to the base 10, where they have given that a is a constant. So this would look like d by dx of e to the power x plus d by dx of log of a to the base 10. When I do this d by dx of e to the power x, it would be the same, which means this is e to the power x itself, plus d by dx of log a to the base 10. It would be a 0. So this comes to an e to the power x. This comes to the e to the power x. Are you clear with this? Yes, can you do this? Are you sure? Okay, so we can move to the next functions. They are the trigonometric functions. Let's look at them. You need to remember this. First, it's a d by dx of sin x, which is cos x, and d by dx of cos x, it would be a sin x. It is a differentiation of cos with respect to x. D by dx of cos x, it is minus sin x. D by dx of tan x, it's a sec square x. D by dx of cot x, it is a minus of cos x square x. D by dx of sec x, it's a sec x into tan x. And d by dx of cos x, it's a minus of cos x into cot x. So take your time, write it down on the piece of paper, because we are going to use this to solve our numericals. Take your time, take a 2 minute of time and write it down. Please be in a hurry. Yes, have you done with this? Okay, let's start practicing this. Let's say they have given that d by dx of sin x plus cos x. You need to differentiate this, d by dx of sin x plus cos x. So this would something like this: d by dx of sin x plus d by dx of cos x. Now differentiation of sine, what is it? It's a cos x, yes. And differentiation of cos, it's a minus sign. So d by dx of cos x, it is minus of sin x. Yes, clear? Let's look at the next is d by dx. Next is the d by dx of sin x plus tan x plus ln x plus e to the power x. What is d by dx of sin x? What is it? It's a cos x. D by dx of 10x. It's a sec square x plus d by dx of ln x. D is 1 by x. And d by dx of e to the power x. This is e to the power x. And that's it. We have done it. Okay. Let's move to the next question. Suppose they have given this is d by dx of x square plus 1 by x square plus 10x plus e to the power x. So if I solve this, what is the d by dx of x square? What is it? D by dx of x square. Yes, it is a 2x plus d by dx of 1 by x square. So this should look like this. If you could not perform it by mind calculations, you can write like this: plus d by dx of 10x, it's a sec square x plus e to the power x, that remains the same. So this is 2x into minus of 2 into x to the power minus 2 minus 1, this is minus 3, plus x square x plus e to the power x. This would be the answer. Yes? Yes? Can you do this? Are you sure? Okay, let's move to the next. Suppose they have given d by dx of sin square x plus cos square x. Now what it could be? What it could be? Yes, this is d by dx of 1. Well, 1 is a constant, so this answer would be a 0. This answer would be a 0. Are you sure? You are comfortable with this? Yes? Okay. Let's do one more question of this category. This is d by dx, and this is d by dx of root x plus 1 by root x plus, let's say, cos x plus e to the power x. That's it. Do it on your own. Do this. So this would be d by dx of x to the power half plus d by dx of x to the power minus of half plus d by dx of cos x plus d by dx of e to the power x. Yes. So the answer would be this is equals to, shall I rewrite this so that things would be easier? D by dx of x to the power half plus d by dx of x to the power minus of half plus d by dx of cos x plus d by dx of e to the power x. Now for d by dx of x to the power half, things would be 1 by 2 into x to the power half minus 1 plus minus of 1 by 2 into x to the power minus 1 by 2 minus 1 plus d by dx of cos x. It would be a minus of sin x and d by dx of e to the power x. This is e to the power x itself. So that should be half into x to the power minus of half, here minus of 1 by 2 into x to the power minus 1 by 2 minus 1, minus 1 by 2 minus 1, this is minus of 3 by 2 minus of sin x plus e to the power x. Yes. If you want to simplify it more, it would be a 1 by root of x, because power is 1 by 2, minus of 1 by 2 into 1 by x to the power 3 by 2 minus of sin x plus e to the power x. Are you done with this? Are you sure? Okay, so let's look at the multiplication rule of differentiation. This is multiplication. Let's say we have two functions. One is the fx, another is the gx, d by dx of fx into gx. So what the rule of multiplication is, they said differentiate first term, let's say, and keep second rule as it is. Now put a sign of addition and interchange their rule. What I mean by interchange their rule is that you have already differentiate f, so now write it as it is, but you have not differentiated gx at a first term, so now differentiate this. Are you comfortable? Are you sure? Can you do this? What is it? Let's repeat. It's a d by dx of fx into gx. So first you need to differentiate f. So let's say it is an f dash x multiplied by gx. G would be the as it is, plus the one term which have been already differentiated, that you need to write as it is, and the other term which has been written as it is, that needs to be differentiated. Did you understand what I mean? Are you sure? Let's look. Suppose it is d by dx of u into v. Now you can consider this is our f, this is our g. So what you need to do is, let's say we write v as it is, so this is v multiplied by, you need to differentiate this is du by dx plus. Now interchange the rule. U has been already differentiated, so you need to write it as it is, multiplied by, this is v, you need to write it as dv by dx. Are you sure? Can you do this? Can you? Are you sure? Let's look. Suppose they have given that d by dx of x square into sin x, d by dx of x square into sin x. What you need to do is, let's say this is your u, this is your v. So what you need to do is write sin x as it is, multiplied by d by dx of x square plus. Now sin x has been written as it is and x square has been differentiated. So what next is, you need to write x square as it is, that is to be multiplied with sin x. So this is equals to sin x into d by dx of x square, this is 2x, plus x square into differentiation of sin x, it is a cos x. Now after this, whatever the basic mathematics permits, you can do this. Let's say you can take a common as an x. So if you common as an x, the things remain would be a 2 into sin x, plus x is the common and x remains, x into the cos x. Yes. Let's look at one more question. You need to perform d by dx of 10x into cos x. Let's say one of the function as a u, another as a v. One of the function as a u, another is the v. So what it would be? How you could do this? So this is equals to, you can write cos x as it is, and you need to differentiate 10x plus you need to write 10x as it is, you need to differentiate cos x. So this is cos x into d by dx of 10x. d by dx of 10x, what was it? Yes, it is sec square x plus 10x into d by dx of cos x, it is minus of sin x. So this is cos x into 1 by sec square x, that means 1 by cos square x, plus 10x, which means sin x by cos x into minus of sin x. So here it is a cos x, here it is a 1 by cos square x, so that remains 1 by cos x sin x into minus sin x. This is minus of sin square x divided by cos x. So if you look like this, it's a 1 minus sin square x divided by cos x. What is 1 minus sin square x? What is 1 minus sin square x? Yes, it is cos square x divided by cos x. So the things remain would be the cos x only. Things remain would be the cos x only. You can check it like this as well. D by dx of 10x. What is 10x? So let's say it's a sin x by cos x multiplied by cos x. This 2 would be gone, and d by dx of sin x would be the answer, which is a cos x. Yes. Yes. Will you able to solve this? Okay, great. Let's look at the one more question of this. They have given this d by dx of x square into log x, d by dx of x square into log x. So what you need to do is, let's say this is u, this is v, this is u, and this is v. So if I write like this, then I can write as d by dx of, let's say, u multiplied by v plus u as it is, and you need to differentiate this, plus u into dv by dx. Are you sure? Yes. Now let's put up the value d by dx of u, which is x square, into v plus u as it is, that means x square as it is, multiplied by d by dx of log x. So this is equals to 2x into value of a v, it is a log x, plus x square into log d by dx of log x. This is 1 by x. So this tends to 2x into log x plus x square into 1 by x. This is 1 by x. This would be the answer. Yes, I hope you are comfortable with the multiplication rule as well now. So let's look at the new rule. It's a differentiation division rule. It's a differentiation division rule. Suppose you have been asked to perform d by dx of fx divided by gx, d by dx of fx divided by gx. So first you need to differentiate this. This is f dash x multiplied by gx. Now the symbol would be the minus. So you need to be very careful, because when it was the addition, when it was the addition rule, this 2 would be added. In a rule of multiplication, this 2 would be added, and when this 2 were added, we don't have any issue that you write it down first term this or second term this, because they are going to add it only. Doesn't matter which comes first. But now look at this. Here these two terms are subtracted from each other, so it means a lot. So first what you need to do is, you need to differentiate the f, and stands in f dash x multiplied by gx minus the rules will be interchanged. So first you need to write down fx as it is, differentiate the g dash x, divide by whole square of g of x, So it should look something like this. Look at this. Let's say you have been given d by dx of u by v. So what you need to do is you need to write a v as it is given here. This is v multiplied by du by dx minus of f of x as it is. So that means u is as it is multiplied by g dash x. This is dv by dx divide by v square Yes, can you solve this? Are you sure? Let's check it out. First you need to solve d by dx of log of x divide by x square. D by dx of log x divide by x square. How can you do this? So let's equate this, that this is my u, this is my v. What I need to write is, the formula is, it's a v into du by dx minus of u into dv by dx divide by v square. So the things would look like, this is x square multiplied by du by dx, this is d by dx of log x, this is 1 by x, minus of u, this is log x as it is, multiplied by dv by dx, this is d by dx square, it's a 2x, divide by v square, v is the x, I need to square it, it's an x to the power 4. So the things would look like, this is x square, this is x, so this would be an x minus of log of x into 2x divided by x to the power 4. If you wish, you can take a common of x and that can be cancelled with this. So it could look like this, 1 minus 2 log of x divided by x to the power 3. This would be the final answer. Yes, are you sure? Can you do this? Let's have one more question. D by dx, which is the d by dx of sin x divided by cos x. I know that you also know that sin x by cos x is tan x and d by dx of tan x is sec square x, but we need to practice this with the help of division rule. So let's do it. Let's say this is u, this is v. Now when I need to differentiate u divide by v, I need to write like this, it's a v into du by dx minus of u into dv by dx divide by v square. So this is equals to v is the cos x, du by dx, it's a sin x, differentiation of sin x, what is it? Differentiation of sin, yes, it is cos x, minus of u, it's a sin x, multiplied by differentiation of cos x, what is it? Differentiation of cos x, try to remember it, it's a minus sin x, divide by v square, it's a cos square x. So this terms would be the cos x into cos x, this is cos square x minus minus plus sin square x whole to the divided by cos square x. So that would be cos square x plus sin square x, cos square x plus sin square x, which is 1, divided by cos square x again, that would be the sec square x. Yes, will you be able to solve this? Are you sure? Okay, so let's wind it up here. We have just practiced a certain very basic differentiations formulas, but this is very helpful. These are going to very helpful for to calculate all the applications of differentiation. So please at least do certain questions from your reference books, from your textbooks, based on the differentiation practice. This is the practice purpose only, because if we have been through with the differentiation, if we have been through with the differentiation, this will help us lot, not only in class 11 but also in class 12. So please do it, please do it. This will help us. Thank you. So let's wind it down. Thank you. Have a good day. Take care. Bye bye.